This tutorial introduces the Purlin command in ideCAD Structural. It covers the logic behind Purlin modeling, including how purlins differ from secondary beams in load transfer. Offset, extension, and connection settings are explained in detail, along with design parameters and deflection limits. The workflow includes manual and automatic purlin placement, division techniques, and tie purlin modeling on wall facades. By the end, you'll be able to model efficient, code-compliant roof and wall framing systems using purlins. Now, let's continue with the Purlin command. I went to the Steel tab and selected the Purlin command. When I clicked once on the command, a window opened, displaying the subcommands from left to right. The first one is the main Purlin command, followed by the tie, then single purlin. There's also a command to define a space truss type purlin. After that, you'll find the R-type purlin command. If you want the purlins to contribute to the system's stiffness during analysis, there's an option to include them in the structural analysis. You also have the options to divide purlins at all intersections or at a single intersection, and finally, you can explode all purlins and convert them to single purlin objects. From the drop-down list, we continue with the UPN 140 section. Clicking on Settings opens the first tab, General, which includes visual settings for the perspective view. Moving on to the Structural tab, you'll find the section Settings. You can select from the drop-down. Click Load Section to access the library, or manually type in a section name and press Enter. Material is currently set to S235, but you can assign any material you like. Under Rotation, there are options to modify the section orientation. If you're using castellated beam sections, the bottom part, currently inactive, will become available, allowing you to enter the number of solid openings at the start and end. In the Placement tab, the options are quite similar to those for secondary beams, which we've already covered. Here's a key point to remember: elements modeled with the secondary steel beam command can support slabs, enabling load transfer. Therefore, slab supporting members in intermediate floors should be modeled using the secondary steel beam or steel beam command. However, elements used on roofs or facades to support sheeting should be modeled using the purlin or tie command. Sheeting only transfers loads to purlins. If you use the secondary steel beam command for roof geometry, you won't be able to place sheeting, and no load transfer will occur. Although the logic is similar, you must use purlin and sheeting on roofs and tie and sheeting on wall facades. For intermediate floors, combine the slab command with secondary steel beam or steel beams so the software can process load transfers correctly. Back to our topic, there are two placement options: count-based and interval-based. Regardless of which one you choose, they are reversible. If you enter a number in the count-based option, the software divides the span into equal intervals. If you use interval-based, the software calculates the count based on total length and writes it in the count box. If the interval doesn't divide evenly, be sure to activate Place Extra Steel on the exact last interval to add the final member. To prevent clashes, you can remove the first and last members or enter offset values. There are three offset options: perpendicular to the first element, perpendicular to the second element, or free offset. You'll need to manually input offset values in the corresponding boxes. The green arrows that appear during modeling indicate offset directions. In the Extension tab, we set the placement to over the top the roof beam. You can choose from over the top, top-oriented, or middle-oriented. If a custom elevation is required, enter a delta value in the vertical displacement box. Under Connection Type, there are three predefined connection options. I'm keeping the default purlin connection. In the Extension tab, you can define cantilever lengths for both the left and right sides, for example, 50 centimeters. In the Division on Intersection section, when dividing overlapping purlins or avoiding conflicts with main elements, set a 1 cm clearance between the intersecting elements. In the Design tab, the software automatically calculates design factors such as unbraced length, LTB, and CB. You can review them in the Design tab after analysis or modify them manually if needed by enabling the checkboxes. Deflection limits should comply with design codes. The default here is L/240, but this value can be customized by the user if necessary. Now, let's click OK and model from the perspective view. The first green arrow appears. Select the first and last beam in the span. You'll see that when I select 150 centimeters as the spacing, the software places 7 members and adjusts the remainder automatically. If I change the first member alignment to perpendicular to the first element and input a small offset to avoid overlaps, the result is more accurate. Now I'll change the interval from 150 centimeters to 100 centimeters and click OK. Let me repeat the same action by pressing the middle mouse button. I selected the first and last beams again, and the purlins were successfully created. Let's apply the same process to the last bay. Let's enlarge the view and test how the divide command works for purlins. There are 2 options: divide, combine all intersections. I clicked it and selected the purlins, and the software split them at all intersection points automatically. You can also use divide combine single intersections. I clicked this option, moved the mouse over a single intersection, clicked once, it merged the segments. Clicking again splits them. This is useful for creating staggered purlin arrangements with manual control. For now, we've used divide all intersections to split all of them at once. Now let's switch to the wall facades. I activated the tie command and selected the first and last column. Since there's no slope here, I can safely use the perpendicular alignment to either element. I've also applied a batch update, something you can do quickly when needed. Let me repeat the same to demonstrate again. The divide command also works for ties. I applied it and completed the split. I won't explain connections in this section, as we'll cover them separately later. Now I want to model ties at this location. You'll notice I left the top open because the slope is different. In this case, using the single purlin command will be more appropriate. When using single purlin, the snap points must be defined accurately. So I selected an element, right-clicked, and went to add custom snap points on object. You can set a custom offset from both ends or divide equally. I entered 10. Now you can see that snap points appeared on the beam. And we completed the modeling using the single purlin command. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.